This shows you a much more advanced stage of construction of the piers, quite massive. When viewed from the shore, they of course look much smaller. This shows you a cross-section of the piers which were built from stone quarried near Point Clare. You can see that they are very massive. They are some 30 meters high, and at the base they are some 30 meters long and 8 meters wide. The next group of slides show you the actual construction, and for each span they had to build a scaffolding with a intermediate pier because the wood was not strong enough. These were built mainly by French-Canadian axemen or carpenters. I use the word axemen because they were able to trim the logs that were used in the scaffolding, and to do this entirely using mainly an axe, which of course meant that it was much less costly construction. So they built these things, as I said, span by span. This picture shows the scaffolding on the sides, and they're laying the floor of one of the spans. In the foreground, there are two men who are reaming the holes. This is a tool, a sharp conical tool, which ensures that the holes are lined up properly. On the side, you can see a gang of 4 men standing. In this enlargement, you can see that there is also a forge there. And these men constitute the riveting gang, and the rivets must be heated, then placed in the hole, as I mentioned earlier, while one man supports the head end with a very heavy weight. Then the other 2 men use hammers to flatten out the other end. This now shows you how such a construction span has been advanced. You can see behind it on the right, you can see the actual truss span already constructed. The tube is still in position, and in fact the tube was left completely in position until the entire bridge was built and a new track was laid on the new bridge, and therefore it was possible to remove the tube. So the traffic never stopped. You can see here again the construction span is moving forward, getting ready to link up into a new position. So the Victoria Truss now was built, the northern half near Montreal was built by Dominion Bridge, whereas the southern half was built by Detroit Bridge, which was related to Carnegie Steel, which was the company that provided the Bessemer steel that went into the truss. The design strength of the steel was 21 KSI, which is 145 megapascals, which is the terms used today. That's the design strength. You can see this is quite a safety factor because the actual yield strength of the material was 35 KSI. So that accounts for its long life.